Okay, let's continue problem 5. They measure the viability of different genotype in the alcohol environment. And then there are 3 genotypes being considered here. The homozygous F, the heterozygous FS, and the and the homozygous SS, okay? And then they ask us to calculate the relative thickness W and selection coefficient S for each genotype. Okay, so how can we find this W? By definition, okay? W, relative thickness, is just equals to the relative viability divided by the maximum value, okay? So to get this value, you just basically find the maximum among these 3, which is 1.2 AA, okay? And then for this one, that value itself, 0.932 divided by the maximum value. Then you found this one. So that's the relative thickness. So basically, that's the survivability compared to the maximum one. Okay, that's the relative thickness. And then you do the same, and then you got these columns here. And then selection coefficient, basically just 1 minus that thickness. Okay, so then just 1 minus this value, then you got this value, and then do the same thing. So after we done, they ask us to find the initial the expected frequency in the next generation. Okay, so it's just like question 4C that we have just done before. This one is like from the initial frequency, and then you got something changed based on the thickness, and then you need to find a new frequency. Okay, so now they give us the initial frequency for the ADHF, right? This allele to be half. Okay, so quite simple because they just happen to equal to each other. Okay, so to find the Q, which is the frequency, I will just write it here again. Q is the frequency for the allele ADHS. Okay. So then we can see that in order for this one to occur, it's the combination of both FF. So then 0.5 times 0.5 to be 20. So this is actually like 0.5 times 0.5. Okay. And then this one also like 2 of P times Q, which means that 2 times 0.5 times with another 0.5. Okay. And this one is Q squared, so it's just like 0.5 square, and then that's it. So then we done the first line here. Okay, now we got the information thickness from the above section here. We put it in here. Okay, then proportional contribution will equals to the initial frequency times with the thickness. Okay, so just this one times with this one, we got these value. Okay, and then when we sum them together, we will see that this is the total. Okay, the total, this one is the total, and based on the proportion contribution of each genotype divided by the total, we can find the relative contribution after selection, just like this value divided by the total. Then you got this one. The total here is 0.779, which we got it from sum up on the 3's together. Okay, I will just like write it down here explicitly. Okay, then you will find the relative contribution for this one here. Oh, let me like this one, and this one. Okay, so it means that the frequency for the ADHF, this homozygous is 0.227. Okay, and for the HF, ADHS. The heterozygous is at 0.627, and then for the other homozygous ADHSS, then there will be 1 point, like this. Now they ask us to find the new frequency, the frequency of the ADHF in these. So we can see the ADHF appear here, two allele in the genotype, and one's here, right? And it means that if we look into this one, 100% we will see that ADHF. It means that the frequency to find this one will be just like the same frequency with the genotype itself. For this one, it's at 0.627. So if we look into this genotype, if we zoom in and look into the allele, we can either see it to be the S1 or then the F1. It's just like 50% for us to find the F there. That's why it's just like 50% of this value, okay? So that's why when you add it together, you will get it to be so 0.227 plus with half of 0.627, okay? And this one is actually 0.314, okay? Then you sum these together, and that's why we got the final one to be this one, and it's just with 2 decimal places, then the final answer is 0.54, okay?